Hello, welcome to Chapter 1, Collecting Data, Part B, Observational versus Experiment. Let's take a look to the new concepts. An observational study is a study in which researchers just observe the reality. They may interact with it for the purpose of collecting the data, but they don't push it in any direction. An experiment is a study in which researchers manipulate the reality in one or another direction to see what happens. More specifically, the main thing being manipulated is usually the explanatory variable. We say that an experiment is well designed when it includes a number of devices that are part of the standard of quality that science demands. The following are the most important ones: control group and treatment group. In a well-designed experiment, we don't want to compare before with after. We want to have one group that receives the treatment group, and another group that receives a placebo or nothing, the control group. How do we decide which individuals go to the control group and which individuals go to the treatment group? This is the crucial question. In most cases, the best option is doing it randomly. We call this random assignment. Don't confuse it with random sampling, which we saw in Part A sampling methods. Let's pay attention to the distinction. Here we have our population. We are going to pick a sample. It is in this moment when we can apply random sampling. The basic example is a simple random sample. So for random sampling, you must know when we pick the sample. What for? To get a sample that is representative of the population, avoiding bias. Final goal, being entitled to a conclusion about the whole population. If the sample is random, there is no reason to believe that any segment of the population has been overrepresented or underrepresented. So whatever we observe in the sample, we can extend it to the whole population following certain probability rules that we will study in chapters 7 to 11. Let's forget now about how we got the sample. The fact is that we have a sample in our hands. We can use it to run an experiment. This requires at least two groups, the control and the treatment group. It is in this moment when we can apply random assignment. We can send half of the sample randomly selected to the control group and the other half to the treatment group. So for random assignment, you must know when we assign individuals to the control or treatment groups. What for? To create similar groups, controlling for confounding variables. And the final goal, being entitled to a conclusion about cause and effect. Let's see this with an example. I will introduce the remainder of the vocabulary as we go over it. We want to study the relationship between drinking alcohol and fluency and articulation reading. We use 500 participants. Half will drink 3 glasses of grape juice and the other half will drink 3 glasses of wine. After 15 minutes, they will be asked to read the same paragraph out loud, and we will measure their fluency and articulation reading in a scale from 0 to 100. Notice that we make them drink the same amount of liquid, 3 glasses, and read the same paragraph. Even the prime matter of the liquid is the same. The wine comes from grapes, but with alcohol. These are examples of direct control. We are directly controlling that some basic confounding variables have the same values in both groups. Then you may think that age could also make the difference. If a person is 85 years old, they may have more difficulty reading than a 20-year-old guy. So for this study, you accept only participants between 20 and 40 years old. This is more direct control applied to the selection of the participants. The level of education might have an impact also. A person who did not finish the high school may read much worse. So you accept for this study only participants with high school but without masters or PhDs. So the other extreme values are also out of the equation. more direct control. Here is the thing, as important as direct control is, it is not the crucial device for controlling confounding variables. Its main problem is that you can apply it to just a very few of them. In the first part of this class, I said that there are as many confounding variables as you can imagine. Indeed, there are many more than you can imagine. There are many that you don't think of, or you cannot measure, or you cannot control directly. Here it is where random assignment comes. Let's say that you run this experiment. 250 participants drank the wine and 250 drank the juice. In the control group, the average fluency and articulation reading score was 85, and in the treatment group, 55. Obviously, this difference was not caused by the difficulty of the paragraph, because everybody read the same paragraph. It was not caused by age or education level, because these variables were also directly controlled. But then you think, maybe shyness could be a reason. Shy people get nervous and don't read so well. Maybe there were more shy people in the group of the wine. And you cannot double check this because the participants are gone and you never measured the variable shyness, if it was possible to measure it. So you don't have any information about this, nor can you generate the information. Here the good news. If you used random assignment, there is no basis to believe that shyness explains the difference. Let's say that in these 500 people, 100 of them were particularly shy. If you used random assignment, the most reasonable scenario is that maybe 52 or 53 of them drank the wine and the other 48 or 47 drank the juice, or vice versa. The point is that the amount of shy people here and here shall be very similar. So there is no reason to believe that shyness hindered the average in this particular group. And what applies to shyness applies to any other possible confounding variable, including those that we are not aware of. That's the power of random assignment. It controls at a time for all the potential confounding variables. This cannot be achieved with direct control. That's why we say that random assignment is the crucial technique to get a conclusion about cause and effect. If we applied random assignment here, it is extremely likely that the only variable that was drastically different among these two groups was alcohol. Therefore, alcohol is the only reasonable explanation for this difference. Notice that random assignment is compatible with direct control. When possible, you want to use both. Some of you may wonder, why do we need to administer juice to the participants in the control group? Why can't we just let them drink nothing? The answer is to isolate the variable alcohol. When you administer wine, 11% of the liquid is alcohol, but you also administer many other things. We want a second treatment that includes as many as those other things as possible, but does not include alcohol. In this way, we are isolating alcohol. We want what we call a placebo. The ideal placebo is as similar to the regular treatment as possible, but without the key component that we want to test. The key component, in this case, is alcohol, and the placebo is the juice. You must know that when you administer a treatment to a person, the psychology of the person may change a lot. And when I say the psychology, I also say the physiology, etc. Not necessarily because of a chemical or physical component of the treatment, but because of the experience of going through it. The ceremony, or the theater as I call it sometimes, of the treatment already has an impact in the individual. This is what we call the placebo effect. The way of controlling for the placebo effect is administering the same ceremony and the same theater to the individuals in the control group. This is a main function of the placebo, controlling for that variable that we call psychology. We say that an experiment is blind when the participants receive a placebo without knowing that it was a placebo. And we call it double-blind when neither the administrators nor the participants know who is receiving the placebo or the actual treatment. Double-blind is even better. So, summarizing, what are the ideal devices that we want to see in an experiment? A control group, a treatment group, direct control, random assignment, a placebo, and double-blind. Very often, it's not possible to combine them all. This particular example is not perfectly blind nor double-blind because those receiving the wine know that it is wine. Exercise 1. Here we have two groups of students, the group of those who attend the math center and the group of those who don't. Students in the first group perform much better than those in the second. So first question, what are the explanatory and the response variables in this study? That's easy. The explanatory is attending the math center and the response is grade in introductory statistics. Label each of the following statements as a valid or invalid conclusion from this study. First, attending the math center improves a student's performance in statistics. This might sound reasonable because those who attended the math center did much better. Let's take a look to the next. Attending the math center helps students pass the introductory statistics course. Here we are saying that it just helps. Attending the math center increases your chances of getting a high score at introductory statistics. Here we say that if you attend the math center, you are more likely to pass. Well, here is the thing. According to the standard of quality that we are introducing in this chapter, neither of these statements is a valid conclusion. The three of them are invalid. Why? Because these verbs, to improve, to help, to increase, imply a causation, a conclusion about cause and effect. And the key concept here is that we can never imply a conclusion about cause and effect from an observational study. This answers question C. This is an observational study. It is an observational study because we are not manipulating the reality in any particular direction. For example, we are not forcing some students to go to the math center. We are interacting with the students when we send them the survey, but this interacting does not qualify as the manipulating that we need for an experiment. Sometimes students think that this is an experiment because they see two groups and a treatment. It is true that there are two groups. One group receives the treatment, the math center, and the other group doesn't. But this is also true for many observational studies. What is missing here is the random assignment. If students had been sent randomly to the math center, then we would consider this an experiment and the conclusions phrased here could be valid. But because they chose to go to one group or to the other by themselves, we cannot get those conclusions. This brings question D. Provide a good phrasing for a conclusion from Professor Villegas' study. We can say something like, attending the math center is associated to higher scores in introductory statistics. By saying associated to, we are not implying cause and effect, so this is fair. You can also say it is linked or it is correlated. We will work with the concept of correlation in Chapter 4. Alternatively, you can also say something like, those students who attend the math center are more likely to pass introductory statistics. By saying are more likely, you avoid speaking of the cause. You just say that they pass more often. You don't say why. So this is also a fair conclusion. This brings question E. If the math center is not the cause of its attendants' superior performance, what confounding variable could then be the cause? A likely answer is will or motivation. Those who attend the math center probably care more about the course and they probably study more and better. In other words, they are better students. But probably they were better students all the time, not just after attending the math center. They might have scored equally well even if they had not attended the math center at all. This brings a provocative question. Could the math center be indeed useless despite of the results observed by Professor Villegas? Yes, it could. Even more, it could be detrimental. This is interesting. Looking just to associations, something that is negative can look like positive. We'll see an example of this in a couple exercises. So let's go to the last question. Design a study able to determine if the math center indeed improves a student's performance in statistics. This must be done with a well-designed experiment. We could work with 100 introductory statistics students with similar academic background. Then we make sure that 50 of them randomly selected attend the math center for 4 hours a week. The other 50 go to the library to study there for also 4 hours a week. At the end of the semester, we compare the average grade of those attending the math center to the average grade of those studying in the library. Here we have a treatment group, those in the math center, and a control group, those in the library. Notice that the library and the studying there plays the role of the placebo, or the old treatment if you prefer. It provides an experience similar to the math center, but without the very elements that are characteristic of the math center. Notice that we are using a bit of direct control when we make the two groups stay in their place for the same amount of time, 4 hours a week, and when we pick similar backgrounds. Most important, we are using random assignment. With this study, you would be entitled to say that the math center improves a student's performance. One final comment. Imagine that you are doing poorly in statistics. Then you begin attending the math center and your performance in statistics improves greatly. Can you tell your friends that the math center is helping you a lot? I think the answer is yes, absolutely. Because when you talk to friends, you don't necessarily have to use the scientific argot. You can speak in a more lax way. But if you are the founder of the Math Center and you are publishing a paper about how useful it is, then you should speak in terms of association or likelihood and not in terms of causation, unless you have conducted a well-designed experiment.